Hey, welcome back to math0110. This is the third and final video for asymptotes, vertical asymptotes and horizontal asymptotes. We started this set of videos with a discussion of limits as x approaches a of a function f of x that result in getting plus infinity or minus infinity out of the limit. Those situations signal the locations of vertical asymptotes at x equals a. Then we moved into horizontal asymptotes, which they come about from limits as x goes to plus infinity or minus infinity. And in the second video, we looked at examples done using a theorem. So if we have a rational function, what do we do? What do we do to the rational function in order to extract what the value of the horizontal asymptote is, if there is indeed a horizontal asymptote for that function. And then in addition to using that theorem, doing the calculation the long way, we have a short way. We have a shortcut based on comparing highest powers. The next thing is to more carefully define horizontal asymptote in terms of this limit. Whenever we find that the limit as x approaches infinity of f of x equals L, whenever that limit gives us a number, so that number L could be 0, could be 3, it could be 5, it could be 10, but anything other than infinity, minus infinity, or some other DNE type of a situation, then we can say that the function f of x has a horizontal asymptote at y equals L. And I really should prepare this definition. This is x goes to plus or minus infinity. So plus or minus infinity. It's either of those or both of those. And I should highlight that L can be a number like 1/2, 1, 0, -3, 7 over pi, etc. Whenever a number comes out of that operation, that limit to plus infinity or minus infinity. So an example of a function that does this is an example, I think this is from the second video, 36x to the 4 plus 5x over 12x to the 4 plus 4x cubed. This, if you compare highest powers, if we use the shortcut, the highest power on top is x to the 4, highest power on the bottom is x to the power 4, so they match. The result of the limit to infinity will be the leading coefficient on top divided by the leading coefficient on the bottom. So 36 divided by 12, we get 3. That signals that there is a horizontal asymptote at y equals 3, keeping in mind that limits give us y values. We plug x values in, we get y values out, just like function evaluations. So it's telling us that as x gets really, really large, as x gets more and more to the right, the function's y value is going to approach 3. It's going to get closer and closer and closer to 3. In Calc 1000, it is sometimes defined more carefully. The limit as x approaches infinity of f of x equals L means that f of x minus L can be made as small as you want by making x sufficiently large. And that's written in a more formal way. But one of the reasons that I think some students struggle with this topic, with horizontal asymptotes, is that we're missing some of that formalism. We're missing the formalism about what a limit to infinity actually means. But it's not part of the course. Don't really want to get into it because it involves a non-friendly notation. I'll leave it for those who go on to the Calc 1000 to explore that. Okay. So you could go back and look at all the previous examples we did in the last video and say, okay, so let's see. So horizontal asymptote of 4 for that one on the left, horizontal asymptote of y equals 0 for the second one, the one on the right. No horizontal asymptote for as x goes to infinity for the one on the left here. Horizontal asymptote y is equal to 0 for one on the right. None and none. and then 3, y equals 3, y equals 0, none, y equals 5, y equals 2, and y equals 0. So just picking off where the horizontal asymptotes are, so how high are they, what are their heights, based on the output of these limit calculations. So another one here at the top, 25x squared minus 2x over 5x squared plus 7. Using the shortcut, highest power is 2, so we look at the leading coefficients, so the part of the expression with that power 25x squared, so that coefficient of 25 on top, divide by the coefficient on the bottom with the x squared, so 5, 25 divided by 5 gives you 5. So y equals 5 would be the horizontal asymptote for that function. In addition to rational functions, we also have horizontal asymptotes for many other types of functions, one of which is the exponential function. So I'm showing here the exponential function 5 plus 3 e to the x. It has a horizontal asymptote of y equals positive 5. Now, where that comes from is actually not the limit to infinity. It comes from the limit as x approaches minus infinity. Let's look at both limits for this. So we'll explore this with a limit as x approaches infinity of 5 plus 3 e to the x. So that's going to be 5, since limits don't change constants, plus 3 times e to the power of infinity. Now, something to a power, like 2 to the power of 3 means 2 multiplied by itself 3 times. E to the power of infinity means e multiplied by itself infinity times. So this is 5 plus 3 times e times e times e times dot 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 e. And that's going to go on forever. E is around 2.7. So I have 2.7 multiplied by itself forever. Like you never stop. Times 3 makes it even bigger. Plus 5. Doesn't do much, but hey, it's something. This is going to be infinity. So we're not getting a horizontal asymptote on the right-hand side. And the graph is shown in red on the slide. But what if we take a limit to minus infinity? Limit as x approaches minus infinity of the exponential function. So 5 plus 3 e to the x. Well, that is 5 plus 3 e to the minus infinity. Let's use exponent laws. A negative exponent we can bring down as a positive exponent in the denominator. So 5 plus 3 over e to the positive infinity. So 5 plus 3 over e times e times e times e forever. E times e times e forever. That's 5 plus 3 over infinity. Now, 3 in infinity odds. So you have 1 in a million odds, that's pretty bad. 3 in a million odds is a little better. 1 in a billion odds is worse than 1 in a million. 1 in infinity odds is really, really bad. 3 in infinity odds is slightly better than 1 in infinity, but not really, they're both terrible. It's essentially 0 odds. 3 divided by infinity is 0. So 5 plus 0, we get the 5 that was claimed. So that's the y value of this function when x goes to minus infinity, not positive infinity. So that is how we indicate the value of the horizontal asymptote for this type of exponential function. And then there's other functions too. There's something called the arctan function, and there's a whole bunch of others, but they're not part of the course, so I'll leave it at that. For us, we worry about exponential functions and about rational functions as far as horizontal asymptotes are concerned. Okay, so let's see a few more. Looking at these types of exponential functions. Limit it as x approaches in. So this is not asking us for horizontal asymptotes, it's just asking for us to do limits of exponential functions. So limit as x approaches infinity of 2 to the x. Now what we're supposed to write is, we're just supposed to write infinity, which means the limit doesn't exist, dne. there's a matter of debate whether or not we say the answer is infinity or we say the answer doesn't exist. It depends on how you want to interpret a limit. You could say it's limitless. You could say there is no limit to how large this function gets as x goes to infinity. So if that's the way you think, then it does not exist. There is no limit. So the limit is non-existent. That's what you would write. But if you think, okay, well, I want to really distinguish between minus infinity and positive infinity, I want to say it's getting positive and large and not negative and large, then you'd write positive infinity. So in some textbooks, you will see the answer given as dne. In other textbooks, you'll see the answer given as infinity. Our textbook says it's dne, and really every time I see one of these, I think it's infinity, based on the textbook that I learned from. But hey, for us, because I'm going to base the exam on the textbook, the exam answer would say dne, and infinity would not be an option for this. Now, that's the answer, but why is that the answer? Because this means 2 times 2, or this means 2 to the infinity, which is 2 times 2 times 2 forever. So you keep doubling, doubling, doubling forever, you're going to get infinity. Okay. We'll go to the bottom one now. Limit as x approaches minus infinity of 3 plus 5 times 5 to the power of negative x. So what we'll get is we'll get infinity from this, which is dne. But I'll tell you why. So this is kind of like the above, it's illegal steps. We're not supposed to write it, but I don't care. I'm going to write it anyway. We have 3 plus 5 to the power of negative x, and x is minus infinity. So 5 to the power of negative infinity. The negatives cancel. 3 plus 5 to the infinity. 3 plus 5 times 5 times 5 dot 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 times 5 forever. So that's 3 plus infinity, which is infinity. Okay, now I'm going to move on to the bottom right. 7 plus 5 to the x as x goes to infinity. This is also infinity, or dne. And here's why. We're going to get 7 plus 5 times 5 times 5 times 5 forever. Oh. So that's 7 plus infinity, which is infinity. And now the last one, top right. The answer here is going to be 4. And here's why. Here's the reason for it. We're going to get 2 to the minus infinity plus 4 minus 7 to the minus infinity. Now let's use the laws of exponents to rewrite these. This is 1 over 2 to the positive infinity plus 4 minus 1 over 7 to the positive infinity. 2 to the infinity is 2 times 2 times 2 multiplied by itself forever, which is going to be infinity. So 1 over infinity plus 4 minus 1 over 7 to the infinity. 7 to the infinity, 7 times 7 times 7 forever. That's going to be infinity. Now we have a lottery with 1 in infinity odds. There's no chance of winning that lottery, so 0 plus 4 minus another lottery with 1 in infinity odds. That's also 0. So 0 plus 4 minus 0, we get 4. Just some practice of doing limits involving exponential functions. So you're either thinking about exponentiation as a type of multiplication to help you determine if you're going to get infinity or not. coming out of the calculation, or you're doing that in conjunction with the laws of exponents. So taking a negative exponent and bringing it in the denominator, making it a positive exponent instead. All right, now we're asked for the horizontal asymptotes of some functions. So this exponential function 2 to the power of x has a horizontal asymptote of y equals 0. Since we have two ways to get horizontal asymptotes, either limit to infinity or limit to minus infinity. Limit to infinity is not going to help us because it's 2 times 2 times 2 forever, which is not going to give us a number for the value of that limit. So I'll put the definition here. We need limit as x approaches infinity of f of x equals L, or limit as x approaches minus infinity of f of x equals L, where L can be 0 or 2 or 3 or 10 or pi, anything except plus or minus infinity. So how are we going to get that? Limit to infinity won't work. Let's check limit to minus infinity. So let's limit as x approaches minus infinity of 2 to the x equals 2 to the minus infinity, which is 1 over 2 to the positive infinity, which is 1 over infinity, which is 0. So we get an L value that exists. Okay, top right. Does e to the negative x have a horizontal asymptote? And it does. It has a horizontal asymptote of y equals 0 as well. But why? How do we see that? How do we determine it? Well, we have only two ways to get the horizontal asymptote. Limit to infinity gives us a number, or limit to minus infinity gives us a number. The minus infinity limit won't help because we'll have negative, negative. We'll have a double negative. We'll make it a positive. That'll give us e to the positive infinity, which is e times e multiplied by itself forever. So 2.7 times 2.7 times 2.7. We're not going to get a nice number out of that. We're going to get an infinity. So since the limit to positive infinity for this one, limit as x approaches positive infinity of e to the negative x equals e to the minus infinity, which is 1 over e to the positive infinity, which is 1 over e times e times e times e, which is infinity, so 1 over infinity, which is 0. Okay, next one, bottom left. That has a horizontal asymptote of 7 minus 0, which is 7. Since, where does it come from? Plus or minus infinity. It comes from the minus infinity. Limit as x approaches minus infinity of 7 minus 2 to the x equals 7 minus 2 to the negative infinity, which is 7 minus 1 over 2 to the infinity, which is 7 minus 1 over infinity, which is 7 minus 0, which is 7. Okay, and then the last one here. This has a horizontal asymptote of y equals 5. Oh, you want to appear in my video? No? It's a math video.
Is my laptop in there?
Yes, it is, but unless you want to appear in my video, you can't get it. You gotta close the door. Oh, you're in my video.
Where is it?
This? Or this? This one. You want this?
Yeah.
Okay. Can you say hi at least? Hundreds of people are going to see you. Hundreds of viewers. Tell them to like and subscribe. Say it. Say it. No, like and subscribe. They can't, by the way. They can't like and subscribe. It's not on YouTube. Anyway. Minecraft video watcher. Just passing through, I guess. This has a horizontal asymptote of y equals 5. Since, is it going to come from the positive limit or the minus limit? Positive infinity or minus infinity limit? Which one? Well, if we plug in minus infinity, we're going to get a double negative. So positive, e to the positive infinity. That's not going to work out so well. We're not going to get a number out of that limit. So it has to come from the positive infinite side. Since limit as x approaches positive infinity of 5 plus 2 e to negative 3x equals 5 plus 2 times e to the negative 3 times infinity. Negative 3 times infinity is negative infinity. So 5 plus 2 over e to the infinity. E to the infinity is infinity. E times e forever. So 5 plus 2 over infinity, which is 5 plus 0, which is 5. Now I want to add 1 to this. I like doing this on the board in class, but I don't have a board, so I'll have to do it here. What about f of x equals 2 to the x plus 2 to the negative x? Does this function have a horizontal asymptote? And if so, what is it? So you might think, okay, it's 0. Since the left part has a horizontal asymptote of 0, and the right part has a horizontal asymptote of 0. The left part comes from the limit as x approaches minus infinity. The right part, that 0, comes from x approaches positive infinity, and 0 plus 0 is 0. Or you might think, well, maybe it cancels out, or maybe maybe something else happens. But I'll show you what does happen when we attempt to take the limit of this expression. So limit x approaches infinity of 2 to the x plus 2 to the minus x. We get 2 to the infinity plus 2 to the minus infinity, which is infinity plus 0. Using one of the results from up above, 2 to the minus infinity just gives us 0, and infinity plus 0 is infinity. Okay, and now we'll try the limit to minus infinity. Since that one didn't give us a horizontal asymptote, maybe this one will. 2 to the x plus 2 to the minus x. So here we get 2 to the minus infinity plus 2 to the minus infinity, so 2 to the positive infinity. So 0 plus infinity equals infinity. We didn't get L, we didn't get a number out of either of these, so there is no horizontal asymptote. No horizontal asymptote. So not every function involving exponentials is going to have a horizontal asymptote. I don't want to mislead you, make you think that all of them do. It's required that we're able to show that the limit as x approaches infinity or limit as x approaches minus infinity gives us a number, 0, 7, minus 2. But some number has to come out of that operation. Okay, and now I'm going to do one more type of example, and that's a type of example where it asks you to do more than one type of thing. It asks you, for example, to find both the vertical and the horizontal asymptotes. So you have to get your definition straight. You have to know which one's which and how to find them. So for each of these, I'm going to start by looking at the vertical asymptotes. I'm going to split each of these panels into two. Actually use a different color for the other one so it's easier to tell apart. Okay, so the first one, when we look for vertical asymptotes, vertical asymptotes when limit as x approaches a of f of x equals not 0 over 0. That's the definition of a vertical asymptote for a rational function, at least. So when is the bottom going to be 0? The bottom is going to be 0 if x is equal to 5 and x equals minus 5. And we can confirm that the numerator at the top is not 0 at either of those x coordinates. Okay, so that's it for vertical asymptotes. That's all we had to do. Second part, horizontal asymptotes. Maybe it'll make more sense to go this way. When limit as x approaches plus or minus infinity of f of x equals L. L has to be a number. And it's not going to matter if we take the plus infinity or minus infinity limit of a rational function. They're both going to yield the same result. It matters for exponential functions and it matters for radical functions. And we're not going to do radicals, limits of square root functions, where the difference between plus and minus infinity matters. That's Calc 1000. You'll see those in that course. So for the sake of simplicity, I'm just going to take the positive infinity limit, and if you feel like you can do the minus to convince yourself that it really doesn't matter for rationals. Limit as x approaches positive infinity of 3x squared over x squared minus 25. The highest power on top is x to the power of 2. Highest power on the bottom is x to the power of 2. They match. So we can use leading coefficients. So 3 over 1, which is 3. Thus, f of x has a horizontal asymptote of y equals 3. So this really highlights that vertical asymptotes, those are constant x values, x going up and down. So x equals a number indicates a vertical asymptote. Horizontal asymptotes are y values going left and right. So y equals a number is how we indicate a horizontal asymptote. Okay, next one. Same question. Find all the vertical and find all the horizontal asymptotes. I'm going to start with vertical. Vertical asymptote when limit as x approaches a of f of x equals not 0 over 0. So bottom equals 0. That means x cubed minus 3x is equal to 0. I'm going to common factor an x out. So x times x squared minus 3 is equal to 0. And I get 3 solutions. I get x is 0. X is positive root 3. And x is equal to negative of root 3. I should check, plug each of these into the top, make sure we don't have 0 on top. So we plug x equals 0 in, you get 0 minus 1, so negative 1 times 0 plus 1, so you don't get 0 on top. Plug in root 3, 3 times root 3 minus 1, that's not 0, 3, and then 3 times root 3 squared, so 3 times 3, 9 plus 1, 10, not 0, so not 0 times not 0 is going to be not 0. And the same thing for negative root 3, you're not going to get 0 for that one either. So it's safe to say that these are our 3 vertical asymptotes. But I did check the top to make sure the top is not also 0. You have to do that. Okay, now horizontal asymptote. When limit x approaches plus or minus infinity of f of x equals L. This is one of those examples we have to fully expand. I'm just going to take the infinite limit. Doesn't matter if we do positive or negative, so I'm just going to take the positive. So I'm going to FOIL out the top right away. 3x times 3x cubed is 9, times 3x squared is 9x cubed. Then I have 3x times 1, so plus 3x. Negative 1 times 3x squared, so minus 3x squared. And then minus 1 times positive 1, I get minus 1. All divided by x cubed minus 3x. The highest power on top is 9, highest power on the bottom, highest power on top is 3, highest power on the bottom is 3. I'm going to use the leading coefficients. So 9 over 1 equals 9. Thus, f of x has HA of y equals 9. That's our answer. And before posting this note, I want to make sure that I at least make a comment that I'm using the shortcut. All right. See you next time.